Your AI agent has a memory problem. Two extremes. Either it forgets everything between sessions, goldfish memory, start from zero every time, or it tries to load all past conversations and drowns in context. 50,000 tokens, slow responses, can't find what matters. There's a better way. The three-layer memory architecture solves both problems. It's how OpenClaw became known for having the best memory system in autonomous AI. 3 layers, each does one thing well. Together, they give your agent memory that actually works. And in this video, I'll show you how JARVIS Phase 5 made it even better. The 3-layer memory architecture. Each layer does one job perfectly. Layer 1, current conversation buffer. This is your active session, the conversation happening right now. Small and fast. 8,000 to 200,000 tokens, depending on your model. Instant access, under 1 millisecond. Layer 2, semantic search storage. This is long-term memory. Past conversations, hundreds or thousands of them, stored permanently. Vector embeddings, similarity search. Finds relevant memories in 100 to 500 milliseconds. Not as fast as Layer 1, but still fast enough. Stored in a vector database. Pinecone, Weaviate, Chroma, whatever you choose. Layer 3, structured knowledge base. This is persistent knowledge, facts that are always true. User preferences, project context, domain knowledge, learned patterns. Layer 3 doesn't change often, but when it does, it's deliberate. You update it manually or through reflection, stored in files or a traditional database. Retrieval takes 10 to 50 milliseconds. Here's the key. The agent uses all 3 layers together. Current conversation in Layer 1. Relevant past experiences from Layer 2. Core knowledge from Layer 3. Synthesizes them into a response that's fast, accurate, and contextually aware. Layer 1 is your conversation buffer. What you're saying right now. Every message you send, every response the agent gives, it all lives in Layer 1 during the active session. This is in-memory storage. No disk writes, no database queries, instant access, under 1 millisecond. The buffer has a size limit, 8,000 tokens for older models, up to 200,000 tokens for newer ones like Claude. This conversation we're having right now, about 15,000 tokens. Still plenty of room. However, when the session ends, Layer 1 clears. That's not a bug, it's a feature. You don't want to carry every conversation forward forever. What happens when Layer 1 fills up? You have 3 options. Option 1, truncate. Cut the oldest messages, keep the newest. Simple, fast, but you lose context. Your agent forgets what happened at the start of the conversation. Not ideal for long sessions. Option 2, summarize. Run the old messages through the LLM, generate a summary, replace detailed messages with compressed version. Preserves key points, but it's lossy. Summaries miss nuance, also costs LLM tokens. Option 3, archive to Layer 2. When Layer 1 approaches capacity, save the entire conversation to Layer 2, your long-term memory. Then, clear Layer 1 for the current session. Best of both worlds. You get fresh buffer space, and nothing is lost. If you need to recall something later, Layer 2 semantic search finds it. OpenClaw uses Option 3. JARVIS uses Option 3. That's the pattern. Layer 1 is temporary. Layer 2 is permanent. Archive regularly, search when needed. Layer 2 is where long-term memory lives. Every past conversation, every decision, every insight, archived as semantic memories. Here's how it works. Every conversation gets converted into a vector embedding, a numerical representation of meaning. 1,536 dimensions or more. Why vectors? Because semantic search. You don't search by keyword. Find me conversations containing the word PostgreSQL. You search by meaning. What database did we choose and why? Vector search finds semantically similar memories, even if different wording was used. This is how OpenClaw maintains context across weeks. Hundreds or thousands of archived memories searchable in milliseconds. Layer 2 search is fast. You ask, what did we decide about the database? The query embeds, searches the vector space, finds the 3 most relevant conversations, all in 100 to 500 milliseconds. Not as instant as Layer 1, but fast enough to feel real-time. Pinecone, Chroma, Weaviate, Supabase. Any vector database works. The diagram shows an embed query, which is done in 20 milliseconds. The vector search takes between 100 to 400 milliseconds, and the retrieval another 40 milliseconds. So you are taking between 170 to 470 milliseconds, which is fast enough to seem to feel instant. Layer 3 is persistent knowledge, facts that are always true. Not past conversations like Layer 2. Not current chat like Layer 1. Timeless knowledge. 4 categories. The first is user preferences, context, constraints. Things like risk tolerance is conservative. Communication style is direct, are examples. These facts don't change often, but they guide every decision. The second is project context. That is, active projects, tech stack, development phase. For example, JARVIS Investment Assistant, Phase 5, Python plus Claude Code gives an active project in the tech space. The third is learned patterns. These are patterns that work, patterns that don't, things you have learned over time. For example, in an investment domain, you might have learned that using 200 SMA confirmation increases win rate by 15%, or trend reversals are hard to time, wait for confirmation. These are lessons learned and documented. The fourth one is domain knowledge. These are facts and references, broker details, data sources, watch lists, business rules, API specifications, and similar long-term knowledge. Layer 3 can be database files, markdown files, JSON files, YAML files, or any other standards like these, depending on your preferences. Watch all 3 layers work together. Question: why is the API slow on Fridays? Layer 1 has current context, or debugging performance. Users specifically mentioned Fridays. Layer 2 searches past conversations, finds 3 relevant discussions about Friday patterns and database backups. Layer 3 loads project facts such as database backups run Fridays at 2 p.m., deploys at 3 p.m. The agent synthesizes all 3. Your backups and deploys overlap with peak traffic. Here you have 3 layers and 1 answer. You get intelligence from synthesis and not just from retrieval. JARVIS, our own OpenClaw-like development, made Layer 2 even better. Number 1, JARVIS improves the search mechanism by using hybrid search. OpenClaw used pure vector search, great for semantic similarity, but misses exact keyword matches. JARVIS combines both, 70% vector search, 30% keyword search. If you search PostgreSQL 14.2 bug, for example, the vector search finds related database issues, and the keyword search ensures exact version matches are found. Best of both worlds. This is more accurate retrieval. JARVIS Enhancement 2. These are pluggable backends. OpenClaw hard-coded Pinecone as its backend storage. JARVIS designed a backend interface. We have started local with Chroma and SQLite. 0 configuration. Works offline. If you need production scale, you can migrate to something like Supabase with 1 environment variable. Now, do you want a knowledge graph? You can add Neo4j without rewriting anything. Your data stays intact. The backend adapts to your needs as your requirements grow over time. JARVIS Enhancement 3, this progressive disclosure. OpenClaw loaded all 3 layers every time. JARVIS routes smartly. Questions about recent issues hit Layer 1 only. Pattern questions search Layer 2. Preference questions load Layer 3. Hybrid queries use all 3. This is the same architecture as OpenClaw, but it is smarter execution. Importantly, you get faster responses and lower token usage. You get intelligence in the routing, not just the storage. Now you have it. This video details how to tackle the memory problems that have plagued so many developers. The 3-level architecture solves the memory problem. Layer 1 for speed, Layer 2 for history, and Layer 3 for identity. Our enhancements in JARVIS made it better with hybrid search, pluggable backends, and smart routing. The 3-level architecture has been production tested across thousands of hours. It is indeed a solid foundation. Use it as such, and add your own enhancements based on your own usage patterns. In our series, we have one more video in the OpenClaw series that examines the OpenClaw plugins, with over 700 developed so far and growing every single day. Make sure you check it out as soon as it is published tomorrow. And if you have not subscribed yet, go ahead and subscribe to the channel. Help us grow while you grow in your knowledge and ability. Also, hit that like button so others will see this valuable content. Finally, ring that notification bell so you know when the next video drops, and you will be one of the first to get the next videos. See you then.